Hi, Alta, can you hear me now?
Hi, Lee. Yes, it sounds good.
Right, this should be better. Sorry, I figured out what the problem was. Too many networks here.
If you continue like this, you might just win the prize for the technical glitch of this conference.
Okay. Well, it's terrible to be talking about high-tech stuff and you can't keep network stable. All right, here we go. Is the screen up?
The screen is up, yes, okay, and it sounds good.
Okay, thank you. Yeah, no, I figured out what the issue was. So to quickly get back, so the location analysis work, the aspects that is of interest to us in particular, is that we're looking at data and the analysis of data that has a location component to it. So the where and the when aspect is probably the most important. And then of course, along this value chain, we generally would then represent and show that information in the form of a map or the geographic container. And then of course you would take that and you would package it into an app. Now, the reason why I put this up is, we're always talking about data layers, spatiotemporal analysis. And, I realize that I use that jargon so often that I may not actually, that I often may be losing the audience in what we're talking about. All right, so the problem space that is of particular interest to us is that companies and society are being faced with increasingly complex problems. And at the same time, digitalization is providing this new wave of innovation to help solve these problems. And in this complexity of problems that companies and societies are facing is the context of location and time. Everything that happens somewhere and at some point in time. And it's this context that we believe is critical to unlocking relevant and value-adding solutions. Now, this aspect, this endeavor that we're on is really around looking at the converged world of spatial analytics and innovative technologies or ICT. And we bring that together, and the understanding of the hunt for insight is what we refer to as geospatial intelligence. Now, with these increased volumes and velocity of data available, we're finding that geospatial intelligence can only be delivered through the efficient harnessing of data and analytics. The work that we are pursuing is really to look at how to harness that data analytics. And what I want to share with you is not only some of the work that we're doing, but what's happening in South Africa around spatial data and analytics and the real world application of the insights that is being produced. Now, a little bit on the market view of what's going on in the sector. Geospatial is gaining prominence as a foundational socio and economic enabler. So by that, we mean spatial analytics underpinned by these volumes of underutilized data that's being collected across enterprises is more and more being recognized as having tremendous potential for driving business intelligence. However, the capability and understanding of how to derive that business intelligence remains the problem. But the opportunity that remains available is when you close that skill gap, you're going to be able to yield great socioeconomic value. The market, the geospatial market or the location market, it's actually on a growth trajectory. And referencing back to the pandemic and everything that happened last year, what we've seen is that people were really interested in understanding the where of what was going on. So, looking at location and looking at maps really became front and center for most people. And that's what we mean by what this market is starting to grow. The global market size in 2019 was $385 billion US, with Africa accounting for about $9 billion US. And in 2020, the Africa segmentation of this sector is looking at about $2.7 billion US. Now, the biggest driver for success in the spatial industry is actually digital capabilities. So when we look at these four sort of major spatial segments, which is spatial analytics, Earth observation, 3D scanning, and positioning, which encompasses things like autonomous driving and telematics, digital capabilities like machine learning, cloud infrastructure utilization, IoT, and big data are all leading to new innovations, which makes feasible business solutions much more possible. Now, what's of particular interest is how the space value chain, the collection of data all the way through to delivering insights and services to users, has been disrupted. And what's been of particular interest in the South African scenario is just how quickly we were able, as an industry, to keep an eye on those disruptions and respond accordingly. Now, there are quite a few players that you would get that sit along this value chain. The South African National Space Agency in particular would operate in what we call the EO satellite operations. So they've got a facility that enables the downloading of data. But what used to be predominantly an international arena, I think that we've seen quite a few South African companies make inroads there. For example, we've got at least 2 or 3 firms that are able to build small satellites. We've had public funding from the South African government that's gone into 2 satellites that produce domestic data. And this data is actually being fed into South African value-added service providers, analytic-led companies that are able to receive the data for themselves and deliver and derive insight. Now, some of the disruptions that's going on, which is quite interesting, is the sort of compressing of the value chain, and how the digital or the digitalization is driving major disintermediation between all of the various players. And what we're seeing is, EO satellite operators delivering their data straight into the big cloud infrastructure, and co-located with that cloud infrastructure are value-added service providers. And to give you an example of what I mean by this, Amazon spoke a great deal about how they're going to be networking ground stations, essentially the infrastructure that downlinks data from satellites, and pulling all of that data straight into the Amazon cloud infrastructure or AWS. And in that same AWS environment, you've got value-added service providers that are able to put in place the analytical workflows that would ingest data, satellite data, run rapid processing chains on those, and then produce insights in a very rapid form for consumers, for commercial market, for government, and for military users. And just on this and looking at this disruption, probably about 4 years ago, we ran a project inside the CSR where we built an integrated value chain. So essentially, a satellite that was developed by CPUT, carrying a very unique payload, a sensor that was developed by the CSR, launched into space, delivering data to an application that was completely locally developed, the monitoring of wildfires. And that entire system then being used to deliver insights, i.e., when will wildfires affect forestry? When does it affect power lines? And all of this being delivered at a global scale. So when we talk about ZA Space, when we talk about the space industry, it's really that we've got world-class capabilities that are keeping track of the disruptions that's happening in the sector, and really using our domestic capabilities to be able to deliver world-class solutions. Now, if I were to start turning attention a little bit to some of the drivers for the geospatial industry, and bringing that, to make it much more relevant to this particular conference, we can see that artificial intelligence is really being considered as one of the major drivers that underpins the various sectors that lives in the geospatial world. So, I spoke about this as being some of the growth areas, which is 3D scanning, Earth observation. So these are the geospatial technology channels, if you wish, the facilitators that enable interoperability between the technology and the ability to deliver value to customers sits in the standards, the use of open data, interconnected systems. And these drivers are actually being or applied across various aspects of this workflow, of this value chain. And I want to spend some time then just talking through how machine learning in particular, some of it applied in the cloud environments, but definitely all of them talking to big data analytics on Earth observation and geospatial data is being used to provide geospatial value towards the world and economy and society. Now, some aspects on this technologies or the technology drivers which determine success and the implications of these is, number one, we're seeing an expanding user base. For many years, a lot of what we were doing in the geospatial world and applying some of these advanced technologies was always considered to be science fiction. And users, you had to get over this barrier of convincing users that it was possible to achieve this at scale in a sort of production environment, so that you could get businesses to actually invest and buy into the solutions that were being developed. What we're seeing is that there's this reducing cost of acquisition of data, of systems, application of advanced processing technologies. And all of this is coming on the back of the speed of data acquisition. And to put this into perspective, there's a company, US-based, that images the entire planet every day. And so the volume of data and the speed of that data acquisition is incredible. And the only way that you can derive insight or deliver value from all of that data is to apply autonomous systems, machine learning, and the big data analytics that comes with all of that onto this volume of data that's arriving daily. Okay, so a quick note on what the value of spatial information to the economy looks like, particularly in South Africa. So South Africans value digital maps at up to 1,795 Rand per user. So that gives us about 17 billion Rands per annum. We've seen that digital maps reduce travel time, location-based data and geospatial applications and devices have an estimated market sizing of 120 billion South African Rands. On the social and environmental side, CO2 emissions from vehicles could be reduced by 12 million tons. We're seeing this because we deliver some solutions into the sector that emergency response times can be decreased by 20%. Something as basic as making sure that emergency response vehicles are routed along the most efficient route to get to their response points is what we're talking about there. And in that regard, reducing driving time and applying smarter vehicle technologies has an economic value of around 3 billion Rands through fuel savings per car per year. So if I were to now dive in quickly into some of the use cases of machine learning in the spatial environment, I've got three use cases that I want to quickly run through. These cut across organizations, so it's not work that's predominantly being done by GeoInt. I hope to kind of give a snapshot of what's happening in the South African sector, what's happening at a global level, and then a little bit of what's happening on a much more, let's say, commercial or business environment. So the first one I want to talk about comes out of the National Oceans and Coasts Information Management System, or what's called OCIMS. This is a 5-year program that's being led by the CSR, but it's really a multi-user or multi-stakeholder environment between environmental affairs, the South African security cluster, fisheries, South African Maritime Safety Authority, the Space Agency. And really, it's looking at several decision support tools that can enable a more efficient and effective use and management of our ocean resources. So, the South African Exclusive Economic Zone, or EEZ, is about 1.6 million square kilometers. That's roughly the size of our total land mass. And it's quite a major economic resource. And the South African government's policy on this is to have to be environmentally responsible while still being able to utilize that economic resource. So what we were looking at back then, so this was some R&D work that was done at the CSR, where we used deep learning for ship detection from a data set or a data source called synthetic aperture radar. And the work that was done was by Dr. Colin Schwegman and Dr. Waldo Kleinans, where deep learning was used to be able to first detect ships in the deep ocean. So the example that I'm showing here is around the Prince Edward and Marion Islands. And the use case here was being able to identify what's called dark targets. So these are ships that are in the deep ocean. You know, the area or the sea around Prince Edward and Marion Islands is probably one of the most inhospitable areas you can find on the continent. You know, very rough seas, but it's also extremely rich from a fishing point of view. The fish stocks in this area are incredibly valuable, particularly what's called the Patagonian toothfish or the Chilean sea bass. And it's a known hotspot for illegal fishing. And so by using synthetic aperture radar from an Earth observation point of view, combining that with AIS, which is ship transponders, we were able to look at dark target detections and identify where these vessels were, and hence alert the authorities to be able to go in and run a much more specific investigation on that. I think the next one, this is some imagery, again, radar imagery or SAR imagery in the Mozambican Channel. And what we're showing here was a 160-kilometer long oil slick or a bilge dump. So this was oil that was, you know, thrown out of a ship as it was moving through the Mozambican Channel. And being able to, I mean, and these oil slicks are an environmental hazard. Depending on where it happens, it could flow into marine protected areas. It could flow onshore onto, you know, onto the beaches and have an impact on the wildlife in those areas. Over and above that, it's quite unsightly. If, for example, you have a coastal municipality that relies on tourism as part of their income. So what was being done here was using, again, some machine learning algorithms around feature selection and classification of oil spill, essentially being able to discriminate between the sea surface and these oily bilge dumps that, you know, that would be floating on the surface. And yeah, this was work again done by the CSR, Dr. Dukani, 2019 and 2020. But what was really interesting was over and above the sort of feature identification and classification, there was some fusion that would happen between different data sets that would not only identify the bilge dump, but also help identify the vessel that was responsible for doing this. And that was sort of correlating the sort of angle or what the bilge dump looked like on the sea surface to the vessel tracks that would have moved through this area at about the same time. Then this is a bit more of an international view, a really innovative company called Orbital Insight that's looking at classification and change detection. And here they use convolution neural networks to innovate around tree type classification. The case here was looking at palm trees or palm oil production. And what they were looking at was, instead of using the usual greenness parameter or color of pixels to be able to identify extent of farming and potentially the health of trees, they started to look at, in addition to dimensions like shape, size, and pattern, on high temporal satellite data. So like I described, that almost daily satellite imagery. And from there, being able to better quantify production and yield for palm oils. Now, some of the complexities that come with high temporal satellite data is that the orbital dynamics start playing a role in the image. So the look angle is not always the same because the satellite might be coming from slightly different angles. You've got slight variations in the distance and atmospheric effects. So it really starts becoming quite a challenging problem to be able to run or to develop algorithms that can consistently identify and classify the tree types. And this is where the robustness of deep learning, for example, has proven to be very useful. And I think the last one that I very quickly want to talk about, which is quite innovative in my opinion, is applying topic modeling to GPS data. Now, we all know that topic modeling is being traditionally used for text classification. But what we found is through just experimentation that applying topic modeling, in this case, we applied LDA modeling, which was able to highlight driver behavior and fleet risk profiles. And by then bringing a spatial visualization dimension onto this, you're able to highlight to insurers, to fleet owners, or fleet managers, certain areas of potential risk where these topics are sort of manifesting themselves, and that enables these fleet owners and managers to better manage the risk of their fleet and their drivers. Now, these in the fleet or in the telematics sector, fleet management, especially given the increase that we've seen in logistics and last mile logistics, has a very significant impact on their businesses as well as on the economy. And finding innovative ways of being able to better classify the risk for these fleets has quite a significant impact on their bottom line. So I wanted to conclude then on some areas of active R&D that is going on around the world, particularly machine learning on satellite and EO data. There's satellite image classification and feature detection. This remains a very active and interesting area. Detection of roads, settlement types, oil and fuel tanks, ships, harmful algal blooms, and eutrophication events. And you can see that these R&D topics cut across both commercial and environmental problems. Using multi-temporal and high spatial resolution or different spatial resolution images for land cover classification. And then fusion between different data types. There's an absolute explosion in the amount of data, the volume of data that is being collected from a myriad of satellites that are going up. And I think that the challenge that remains, these satellites all have different spatial properties, different types of satellites, optical and radar or point signals. So whether it's AIS, which is ship transponders, or GPS, and different imagery types, through fusion and then applying very interesting algorithms that is able to exploit the benefits of fusing these different data types, you could get greater insights and new solutions being developed. And thanks. So that's my last slide, and thank you for the time. Sorry for the early disruptions with the connectivity, but I hope that I was able to recover at least from not being the worst presenter from a technical point of view.
Thank you very much, Lee. So I will open the floor for any questions.